Okay, so I'm going to give you a quick review of some of the things that we've done over the past two lectures, right? So we started talking about Fourier series representation of periodic signal. So if you're given a periodic signal x of t, a continuous time periodic signal x of t, with a period capital T and a frequency which is omega naught equals to pi by t, its Fourier representation or Fourier series representation is given by x of t equal to summation from k equals minus infinity to plus infinity a k e raised to power j k omega naught t, right? So this would be the Fourier series representation for this periodic signal. For what that essentially that states is a periodic signal can be represented as a linear superposition of harmonically related complex periodic exponentials, right? You just add them up, weight them properly, weight them appropriately, and you will be able to get the any periodic signal, or for all intents and purposes, all practical signals, periodic signals that we come across can be represented in this form. And this is called the synthesis, right? So we said, Kiji, this is the synthesis expression, right? Because this allows us to synthesize periodic signals as a sum of complex exponentials, right? Now, what was the analysis expression? Analysis was if you were to find these AKs, which are called the Fourier series coefficients, they are equal to 1 upon t integral over this, and this is x of t times e raised to power minus j k omega naught t times dt. And this is called the analysis. And this allows us to compute these Fourier series coefficients, which are AKs for all k, for all integer values of k. Now, if I may, what does this notation mean here? When I put up an integral, and then I just write capital T at the bottom. I mean, what does this mean? So who's going to help me? So what does this mean if I put the integral and put a T, capital T at the bottom?
Can I?
Ji Abdullah.
So it means that we'll integrate it over one period, starting from any t0 to t0 plus t.
Right, good. So ये कौन सा अब्दुल्ला था? अब्दुल्ला निसार?
जी sir.
Right. So you're absolutely right. Okay, it just means you're integrating over any period. You can start anywhere, at any t naught, and as long as you're integrating over one period, this is what this you're going to get the same answer, right? So because everything is periodic, and we talked about why this is so, right? Acha. So this was the synthesis and the analysis expressions. And we applied this to some square waves. We found out what these Fourier series coefficient for the square wave was. We found out for the exponential, I think was a decay or forget, or growing exponential periodically repeating itself. And we found out the series coefficients for that. And then we started talking about some properties, right? Okay, what are some of the properties of these Fourier series? And the first one we talked about was linearity. And what that just means is if I give you a signal x of t, which is periodic and has Fourier series coefficients AKs, another signal y of t, which has Fourier series coefficients b sub k, and both are periodic with the same period, right? So that's essential here with period t, the same period here. Then the linearity principle just states that if I form another signal, which is capital A times x of t plus capital B times y of t, the Fourier series decomposition for that, these Fourier series coefficients are going to be capital A times A sub k plus capital B times B sub k, right? So this is another thing we did, right? So the first property we did. And the second property we did was time shifting. And that just stated that if you shift x by some t naught, right? And of course, it's clear that shifting by t naught should maintain that periodicity. The period remains unchanged. The Fourier series coefficients for this are given by ak, what they were originally multiplied by e raised to the power minus j k omega naught times t naught, right? So, and then we argued, okay, this is just a change in the phase of the Fourier series coefficients. The magnitudes of the Fourier series coefficients stay unchanged. Okay, so this is, I think, where we ended, right? So now what we're going to do today is just continue our discussions on these properties. We're going to discuss a few more, and then discuss a few examples in which we're going to apply these properties for computing the Fourier series decomposition for some periodic signals. Okay, so let me go back to the original notes. Um, so time shifting we've done, right? So we're going to start today with the third property, and that is time reversal. So this is the third property, and this is time reversal. Okay, so once again, if x of t has Fourier series decomposition, and the Fourier series coefficients are given by a sub k's, right? So this is sequence, right? The question then is, okay, what are the Fourier series coefficients of x of minus t? And let's say they are bk, and my job is to try to relate this bk's to ak's, right? So the bk's must be somehow related to ak because x of minus t is related to x of t. So therefore the Fourier series coefficients of this new signal, which is a transformed signal, must be related to the Fourier series coefficients of the original signal, and my job is to determine what that relationship is. Okay, so how do I go about this? I mean, how do I determine what these Fourier bk's are going to be? What should be the first step? Similar to what we did last time as well, by the way. क्या करें?
सर वो इंटीग्रल लिखेंगे जो 1/t वाला होता है.
Okay, integral होता है 1/t वाला. इसका मतलब you use the analysis equation, right? So the analysis equation here is, if I just apply that, I'd say कि यार bk's. अच्छा, if I flip flip in the time axis, right? If I flip the signal in the time axis, do I expect the time period to change? No. Okay. So the time period should stay exactly the same, right? So time period should stay exactly the same, right? And so therefore bk can be found by just using the same t, right? And this is going to be integral from over t, and this is x of minus t e raised to power minus j k omega naught t dt, right? Why do I have x of minus t here? Because the signal that I wish to compute the Fourier series coefficients of is actually x of minus t, right? So I just apply the definition for the which is the analysis definition, analysis expression, okay? And integral over t would be this, let's say, okay? Now, how do I relate this to the Fourier series coefficients of x of t? क्या ख्याल है? I mean, how do I relate? I mean, I need to somehow transform this relationship into something which looks like AKs or is a function of AKs, right? So a change of variables. Okay. What change of variables? Change t to tau? What does that mean? And what should tau, t and tau be? I mean, how should they be related? So it would be much easier for me if you, I mean, chat window make a bajai, right? So I mean, just unmute yourself and speak up, okay? Or perhaps raise your hand. I mean, that would be easier, right? So you change it, you use a change of variables, and that change of variables is minus t equals tau, right? That's a change of variables that I'm gonna make, right? So as a consequence, this becomes 1 upon capital T, and this is x of tau. This is e raised to power j k omega naught tau, and dt is the same as minus d tau. So this is d tau, and there's a minus sign here outside. Okay, so there's a minus sign here outside, and this is 0, and this is minus t, right? Now I can incorporate the minus sign inside of the integral. So this is 1 upon capital T. This is minus t from minus t to 0. This is x of tau e raised to power j k omega naught tau d tau, right? And this therefore is equal to 1 upon t. Integral from minus t to 0 is still an integral over one period. This is x of tau, and this is e raised to power j k omega naught tau d tau. How is this related to a? How is this related to ak or a sub k? What's the relationship? Right. So remember, ak is equal to G Hamza.
Sir, if I am understanding this properly, I think this is the conjugate as the signs of the
No.
complex numbers are switched. All right.
अगर conjugate होता तो x का भी conjugate लेना चाहिए था ना?
जी सर, ठीक हो गया.
Right, but that's that, so that is not exactly right. I mean, you're close. So how does it relate to? So you see, I mean, you have the definition of AK in the green up above, and you have this BK in blue down below. I mean, how are they different? Hassan, they're not the same. I mean, what's different? Chale, Hassan, what's different? I mean, if they were the same, what you were really saying is that if I flip the times domain signal, the Fourier series coefficients do not change at all. But there should be a one-on-one correspondence. Should be a one-on-one correspondence. Okay, Ji Hamza, Rashid.
सर इन दोनों का फेस तो जो इनका पीरियड है वो तो सेम है.
Yeah.
तो सर और सिर्फ ये रिवर्स्ड है y एक्सिस पे.
Okay. What do you mean by reverse है y axis पे? So जो time domain signal.
मतलब सर जिस तरह हम देखते थे कि 0 से t तक है और 0 से नेगेटिव t तक पीरियड्स हैं, तो सर ये 0 से नेगेटिव t वाला रिप्रेजेंट कर रहा है.
नहीं, लेकिन
मैग्नीट्यूड
मैंने
सेम
फ्लिप राउंड
होगा.
कर लिया था हमजा. मैंने तो फिर ये देखें यहाँ पे मैंने उसको फ्लिप राउंड कर लिया था, राइट? फिर ये माइनस टी टू 0 हो गया था, और माइनस टी टू 0 इज इंटीग्रेटिंग फ्रॉम द लेफ्ट टू द राइट ओवर वन पीरियड, राइट? सो यहाँ से मैं यहाँ पे आ गया, राइट? ओनली डिफरेंस इज in between this equation in green and this in blue is there's a negative sign here in green and there's a positive sign in the exponential in blue down below. तो फिर मैं क्या करूं? So असद वड़ाइच ने कुछ माइनस ए के का कुछ कहा है. What do you mean by that?
सर शायद वेरिएबल्स को वापस tau equals minus t कर दिया मैंने.
tau equals minus t कर दिया, राइट? बट माइनस ए के कहाँ से आ गया?
एक्सपोनेंशियल में tau equals minus t हो जाएगा और d tau शायद minus dt हो जाएगा.
ओके, दानियाल.
सर if I'm not wrong, तो ये bk के एक्सप्रेशन में e की पावर पॉजिटिव j के ओमेगा नॉट t, ये तो एक एक्सपोनेंशियली राइजिंग होगा ना, ये मतलब ये तो डाइवर्जेंट होगा.
No, not necessarily. I mean, actually not, because this is complex exponential. Remember, complex exponential is the sine side. It's neither decaying or is not growing. ठीक है, ये तो वो तो उसना कर रहे हैं, ठीक है? तो I mean, the answer is really simple here. So this is 1 upon t. Somebody else, Abdullah, आपने हाथ खड़ा किया मेरे ख्याल में.
Sir, I think if we plug in omega naught is equal to 2 pi by t, we can prove that the both exponentials are the same.
No, they're not the same. देखो, exponential एक इस तरफ घूम रहा है और दूसरा दूसरी तरफ घूम रहा है. So their directions are different.
Okay.
ठीक है, so they cannot be the same. Right, Talha?
सर ये जो आपने ये जो एरो लगाया हुआ है -t to 0 जा रहा है, हाउ इज दिस? आपने इसको उसके बाद क्या किया है ये वाई इसका अभी स्टेप में वो t किस तरह कर दिया वो यूनिट?
वो मैंने, so this goes back to our last class जिसमें I started with this कि यार इसका मतलब क्या
I understand इसका मीनिंग तो ये है कि दिस इज वी आर इंटीग्रेटिंग इट ओवर वन पीरियड, राइट?
yeah
सो इट डजंट मैटर ये पीरियड है कौन सा?
yeah it doesn't that's what I said in the beginning of the last class. It does not matter the period constant, right? So this is something we discussed in the last class. Okay, right? So here's GC. This is x of tau. This is e raised to power minus j minus k omega naught tau t tau, right? Simple enough, right? So I just यहाँ पे positive sign था, उस positive sign को मैंने I just say this is minus j, I bring it to that form, and just there's actually a minus k here, right? And therefore this is actually equal to a minus k, right? So this bk here is really x of minus t के साथ जो Fourier series coefficients हैं, those are related to the original Fourier series coefficients as a minus k, right? इसका मतलब क्या है? If when I say कि bk equals a of minus k, b or b sub k is equal to a sub minus k, what does that mean? That means that the Fourier series coefficients are just flipped, right? If you flip the time domain signal along around the y-axis, the Fourier series coefficients are flipped as well, right? Around 0. What that means is that b plus 1 is going to be what a of minus 1 was, and b of plus 2 is going to be what a of minus 2 was. Similarly, b of minus 1 is going to be what a plus 1 was. So the Fourier series coefficients are just flipped around k equals 0. Okay, so that's what time reversal does. It just flips the Fourier series coefficients, right? Is that clear? Any questions here before I move ahead?
Sir, isn't this like एक ही function के दो parts? एक ही function का x of वो positive part after 0, or x of t and x of minus t are different?
X of t and x of minus t are different. Of course, they're different because one is the flipped version of the other.
So okay, I get it.
They will be only the same when they're even signals, otherwise not. ठीक है? अच्छा, हमजा राशिद ने you want to say something, हमजा?
Yes sir. सर जो मैं बात कर रहा था, how is it different from मेरी बात से किस टाइप डिफरेंट है a minus k? सर मैं भी तो यही कह रहा था कि वो फ्लिप ही होगा.
आप क्या कह रहे थे? आप कह रहे थे टाइम एक्सेस फ्लिप होगा.
जी.
देखिए टाइम डोमेन कुछ और है, फोरियर डोमेन कुछ और है.
ठीक है. नहीं तो सर ये सिग्नल की जो शेप वो सेम नहीं होगी वैसे?
नो, सिग्नल देखिए so if there's a periodic signal which looks like, so here's a digression here. So periodic signal here which looks like if this is 0, ठीक है, और ये जो है ये है और ये है. Let's say this is a periodic signal. इसको फ्लिप करें तो वही सिग्नल आएगा, नहीं आएगा?
नहीं सर.
नहीं आएगा. Right? So your flipping does not necessarily keep the original signal unless that is even.
हाँ, ठीक है सर. ठीक है.
अच्छा, हमजा रफी.
जी सर, मैंने पूछा था कि व्हाट इसको इन टर्म्स ऑफ सिंथेसिस इक्वेशन जो आपने पहले लिखी थी उसमें कैसे एक्सप्लेन करना है, क्योंकि अब आपने k को माइनस कर दिया, तो विल इट गो फ्रॉम पॉजिटिव इन्फिनिटी टू नेगेटिव इन्फिनिटी, मतलब उल्टी डायरेक्शन के अंदर हम इसको इंटरप्रेट करेंगे?
necessarily. I mean, so you just say it just means कि जी आप अगर कहें कि जी अब x of minus t जो है, so x of minus t is equal to summation k equals minus infinity to plus infinity, right? And this is bk e raised to power plus j k omega naught t, right? That's what it just means. और लेकिन I say कि जी ये जो है k equals minus infinity to plus infinity, and this is a minus k, and this is e raised to power j k omega naught t, right? What that means is कि जो e raised to power plus j omega naught t के साथ कोफिशिएंट पहले अटैच था, अब वो e raised to power minus j omega naught t के साथ अटैच हो जाएगा. I mean that's what it all means, right? Similarly, e raised to power plus j2 omega naught के साथ जो पहले कोफिशिएंट अटैच था, now it's going to be attached to e raised to power minus j2 k omega 2 omega naught. Okay, so they're just flipping around. That's it. But the summation is still going from minus infinity to plus infinity. I mean, it really depends आप कहाँ से कहाँ लेके जाना चाहते हैं. ठीक है, interpretation in minus infinity plus infinity is the right interpretation.
ठीक हो गया सर, thank you.
ठीक है. All right. Now let me say a little bit more about this for special classes of signal, right? So what we concluded is if you flip the time domain signal, the Fourier series coefficients also flip as well, right? So here's the question: what if the signal is real? Right? What does a real signal mean? Right? A real signal says here x of t equals x of minus t, right? Oh, sorry, my real kya raha hu is even. Right? If a signal is even, then x of t equals x of minus t, right? If x of t equals x of minus t, what can I say about the Fourier series coefficient?
They are the same too, sir.
फिर से बोले, मसला था मेरे ख्याल में ये, आवाज कट गई आपकी.
Yes, sir.
Masna, I couldn't hear you properly. So Hamza, Rafi says they're even, right? So Hamza, why do you think they're even? The Fourier series coefficients.
Sir, because they satisfy the basic definition that we put forward for even signals. So maybe that is extended to this domain as well.
Why maybe?
सर क्योंकि हमने उनको डिफाइन फंक्शंस को और सिग्नल्स को हमने इसी तरह डिफाइन किया था कि जब भी x ऑफ t इज इक्वल टू x ऑफ माइनस t, जब उसका आर्गुमेंट t, जब आप उसका आर्गुमेंट रिवर्स कर देते हो तो तब द आंसर रिमेन्स द सेम, द आउटपुट रिमेन्स द सेम. तो इस केस के अंदर भी अगर वही सिनेरियो रह रहा है, सो द मतलब लाइक मुझे लग रहा है कि यही होगा सर.
लग नहीं, so there should be sound reasoning for your answer, right? So अगर if I say x of t has Fourier series coefficients a sub k and x of minus t has Fourier series coefficients given by a of minus k. I mean, is there information here for you to conclude that the Fourier series coefficients must be even as well? If two signals are equal in the time domain, if two periodic signals are equal in the time domain, and since there's a one-on-one correspondence between the Fourier series coefficients and the time domain signal, therefore the Fourier series coefficients must be the same as well, right? If x of t equals x of minus t, if x of t equals x of minus t, if these are the same, these must be the same as well, right? Because there's one-on-one correspondence, right? So which implies okay, a k's must be equal to a of minus k, right? So from here we conclude that if the answer to this is okay, the Fourier series coefficients are symmetric as well. Or even as well. So therefore, saying ak equals a of minus k. In other words, a of plus 1 is going to be equal to a of minus 1. A of plus 2 is going to be equal to a of minus 2. A of plus 3 is going to be equal to a of minus 3, and so on and so forth. Right? What if the signal was odd?
Minus a of 3 is equal to a of minus 3, and minus a of 3 is equal to a of minus a of 3 is equal to A of minus 3, and
Can you Emmett, generalize that? I mean, instead of just saying 3.
A of k is equal to minus A of minus k.
Good, right? So excellent, right? So A of k, and there we have an answer in the chat box as well, which is A of k is going to be equal to, A of k would be equal to minus A of minus k, and which basically would mean that they are anti-symmetric. Right? So they're, and otherwise it's a sort of odd. The Fourier series coefficients themselves would be odd, right? So in this particular case, what can I say about A0?
Could you repeat that? What, sir?
What can I say about A0? If the signal is odd, if the signal is odd, if the periodic signal is odd, what can I say about A0? And Hassan says it's 0. Why, Hassan?
It must be at A.
Okay.
Sir, because we wouldn't be able to satisfy this condition.
The only way you can
to do
satisfy this condition is with 0.
Yes, yes.
Right? So you say, Kidi, so here, of course, say A0 equals minus A of 0, and the only number that satisfies this condition is 0, right? The only number that's that is the negative of itself is 0. Okay? All right. Okay. I quickly want to talk about another property here, which is time scaling. Right? What do I mean by time scaling? What that means is, okay, x of t has Fourier series coefficients given by a's, right? What can I say about the Fourier series coefficient of x of alpha t? Right? Now, the question is the following. If I take x of alpha t, right? Is x of alpha t periodic? That's the first question. What's the answer to that? Is x of t periodic? X of alpha t periodic if x of t is periodic as well? G. Abdullah.
Yes, it will be periodic. It will be just scaled down or scaled up depending on the value of alpha.
Depending on what the value of alpha is. So what can you tell me कि उस नए signal का period क्या होगा?
T by alpha.
T by alpha, excellent, right? So I think this was a problem, homework problem as well. Okay, it's periodic with a period T by alpha, right? Where implicitly, I mean, I'm saying that the x of t का period t, capital T था. If the period for x of t was capital T, the period for x of alpha t is going to be T by alpha, and the frequency is going to be alpha times capital T. Sorry, alpha times omega naught, right? But nevertheless, so if I just look at the synthesis expression, I say if x of t equals summation k going from minus infinity to plus infinity, a k times e raised to power j k omega naught t, I just look at what x of alpha t is, right? I just plug in alpha t, x of alpha t from the synthesis equation. So what would I get? I would still get the summation where all I will do is just replace t with alpha t, right? And then if I do some manipulation here, I see that this is a sub k, this is e raised to power j k, and then this is alpha times omega naught times t, right? So this is what x of alpha t is, right? So the conclusion that we have here is that, so with time scaling, the Fourier series coefficients have not really changed here, right? But the frequency as the representation does change in the sense that the frequency is either scaled up or scaled down because of that scaling, but the Fourier series coefficients remain the same. Okay? So with time scaling, so this is the conclusion. So with time scaling, the Fourier series coefficient, the coefficients themselves do not change. But the frequency does, okay. Or time period does. Okay, so let me talk about conjugation. And this is where we'll try to answer some of the observations that some students made in the first class that we did, right? So if you recall, one of the observations that a student made, I think Hassan, it was you who made it, which was you observed that the Fourier series coefficients that we computed for one of the signals that we had turned out to be conjugate, right? So a plus 1 we found out was conjugate of a of minus 1. Okay, if you recall, right? So they were complex conjugates of each other. So that's the question that we will have answered after we've talked about this property. Okay, so the question is the following: if x of t is periodic with a period of t and has Fourier series coefficients given by a sub k's, the first question I have for you is what are the Fourier series coefficients for x conjugate of t? And let's say those are BKs. And once again, I want to figure out here, how are these BKs related to AKs, right? So in other words, if I do a conjugation in the time domain, what happens in the Fourier domain? What happens in the Fourier series coefficients? Okay, so how do I go about this? How do I try to derive that relationship? क्या करें? Change j to minus j, all right, or use the definition, all right. Okay, good, right? So take its conjugate, okay, right? So here's what I will do, right? So first off, I'll just use the definition as I think Hassan said, right? So I use the definition, which is BK is, by the way, taking the conjugate, does does it do anything to the time period? Let's say if I have a periodic signal, right, which has a period capital T, and I just take the conjugate of that. Does the periodicity change? And the answer is no, right? Should not change period. Excellent, right? So the period does not change and the periodicity properties do not change. So the period remains the same, right? So BK is going to be, I am going to compute that with the same capital T, and this is going to be over 1 period T. And what do I have here? This is X conjugate of T here. And this is e raised to the power minus j k omega naught T dt. Okay. All right. So now how do I relate this to A's? How do I relate this to A? अब क्या करें? Hassan, do you wanna? You were saying something in the chat box. अगर आप
Sir, हमारे पास यहाँ पर x conjugate t है ना? We have a definition for xt as well, जिसके अंदर हमारे पास AKs हैं. तो हमें उसका conjugate लेना चाहिए.
Okay.
So I think exponential में change हो जाएगा हमारे पास because that's complex, and I guess here we also assume that our AK is also a complex number in general.
Yeah,
so
of course.
So A minus k हो जाएगा. Minus k was a conjugate हो जाएगा.
Okay. All right. So you're actually correct, but I will go through these steps to baby steps, ठीक है? Which are BK. अगर मैं इसी number का, if I take the conjugate of this twice, right? So let me take the conjugate first and then conjugate second time, right? I don't really change the number. If I take the conjugate of that twice, I mean, I'm back to where I started out with, right? So if I do that, and then I just evaluate the inner conjugation, this is 1 upon t, this is capital T, this is x of t, so x conjugate of t ka conjugate is x of t, and e raised to the power minus j k omega naught t, the conjugate of that is e raised to the power plus j k omega naught t. Okay. Now, what do I have inside the brackets here? So what is this thing here? I mean, we just did this in one of the properties that we, excellent, Daniel. So Daniel says this is a of minus k, which is exactly right. This is a of minus k, as we did in the time reversal property, right? So from here, what we conclude is that bk's, which are the Fourier series coefficients of the conjugated signal, is going to be equal to a of minus k and conjugate, right? So which is essentially a conjugate of minus k, or a of minus k conjugate. Okay? So here's the result. So in conclusion, so bk's here are actually equal to a of minus k conjugate. Okay? So when you take the conjugation in the time domain, when you take the conjugation in time domain, what happens in the Fourier domain? Fourier domain, where there are two things that go on. First is there's a flipping of the Fourier series coefficients around k equals 0, just like time reversal. And then on top of that, there is conjugation as well. Okay, so that's a key result that we've derived. Okay, now from this result, I mean, there are several things that we can now infer, right? The first is, so if the signal x of t is real, and we want to see here if the signal x of t is real, are there some special properties that the Fourier series coefficients satisfy or not? Okay. So who can help me here? Okay, if x of t is real, and if I know for a fact, okay, x of t has Fourier series coefficients equal to ak, and x conjugate of t have Fourier series coefficients as we've derived a minus k conjugate. And if x of t is real, what can I say about the Fourier series coefficients? Anybody with a?
Sir, isn't it going to be the same?
Is it? What do you mean by that, Manur? Going to be the same? Okay, Manur. Hamza, when you say just time reverse or flipped, वो तो हो गया ना, लेकिन सिग्नल रियल होना का आपने यूज किया अभी, हमजा?
Sir, I interpreted in this way कि अगर आपका सिग्नल रियल होगा तो it won't have a complex part. तो अगर आप सिर्फ कॉम्प्लेक्स पार्ट को इसमें से रिमूव कर देते हो तो कॉन्जुगेशन वाला भी सारा एलिमेंट निकल जाएगा. तो सिंपल आपके कोफिशिएंट्स जो होंगे वो रिवर्स हो जाएंगे. यू डोंट हैव टू टेक अ कॉन्जुगेट ऑफ देम अगेन, क्योंकि कॉम्प्लेक्स पार्ट नहीं है उसका.
So, I mean, what are you saying? I mean, can you? इसका क्या मतलब है? A case का क्या होगा? A case, are you saying A case are going to be real as well?
सर मैं कह रहा हूँ कि अगर ये रियल होगा तो x conjugate of t जो आपने लिखा दिस वुड बी इक्वल टू a sub minus k. Conjugate का साइन हट जाएगा ऊपर से. That is my interpretation of it as of now.
What can you say about A's therefore?
What can I say about
A case? I mean, is there a special condition to satisfy? लेकिन जो अभी आपके ऊपर ब्लू में आपके पास ब्लू में लिखा हुआ है, ये तो आपको पता है, no matter what signal is, no matter regardless of whether the signal is real or not real, right? I know that these two conditions hold true, right? And Daniel has something interesting which says that if the signal is real, and which is excellent, exactly right. Daniel says that if the signal is real, then x of t equals x conjugate of t, right? So therefore, it means they are equal in the time domain, right? If they're equal in the time domain, they must be equal in the Fourier domain. So these coefficients must be the same as well. Therefore, as I think Hassan pointed out in the chat box, this implies that AK must be equal to A minus K conjugate, right? So if the signal is real, the Fourier series coefficients must satisfy this condition. And is this a condition that we saw earlier? Yes, we did. And as somebody observed directly from those examples, which was, we found out that A plus 1 जो है, वो A minus 1 का conjugate निकल आता है. A plus 2 है, A minus 2 का conjugate निकल आता है. In other words, A plus 1 and A minus 1 are actually conjugates of each other. A plus 2 and A of minus 2 are conjugates of each other. A of plus 3 and A of minus 3 are conjugates of each other, and so on and so forth. And in general, AK and A minus K are conjugates of each other. Okay? So if a signal is real, we say that the Fourier series coefficients are or must be conjugate symmetric, or are conjugate symmetric. So that's what we say. If the signal x of t is real, the Fourier series coefficients satisfy this encircled property, and this encircled property means that the Fourier series coefficients are said to be conjugate symmetric, right? What can I say about A naught if the signal is real? If the signal is real, what can I say about A naught? Right. So if the signal is real, then A naught is going to be equal to A minus 0 conjugate, right? In other words, but A naught is A of minus naught is just A naught, and therefore, as Daniel rightly points out, that A naught must be equal to A naught conjugate, which means A naught is real. Okay. Right. Excellent. Now here's, so for all real signals, the Fourier series coefficients satisfy this conjugate symmetry property, right? So agar aapko, if you know the Fourier series coefficients for all positive k, you automatically know the Fourier series coefficients for all negative k as well, right? And A naught will always be real. And by the way, I want to take a look at what A naught really is, right? So here A naught kya hota hai, right? So A, according to definition, A naught is equal to 1 upon t. This is x of t e raised to power minus j times k, which is 0, times omega naught times t times dt. But e raised to power 0 is just 1. And therefore, this is 1 upon t integral over t x of t dt. So this A naught is sometimes called the DC value, right? Or it's the average value, right? Because why is it called the average value? Because all you're doing is you're taking the signal, finding the area under the curve of that signal over one period, and just dividing that by capital T, and that's the average value. And since x of t is real, I mean, just by looking at this definition, A naught must be real because x of t is real, and just integrating a real signal, you can get a real value. Okay? So it makes sense from another perspective as well, from another definition as well. Agar ye, I found out from this definition that A naught is real just by looking at the definition of the synthesis or the analysis expression. And agar iske alawa koi aur result aata mere paas from all of the analysis that I did earlier, that means I must have made a mistake. Okay? But everything is consistent, thankfully now, right? So itna bhi karke humne dekha, usna bhi karke dekha, and every way A naught does turn out to be real as it should. Okay. Now, the second point is let's say if x of t is real, is not only real, but it's also even. What can you say then? Right. So if x of t is real, because the signal is real, I know from the analysis that I've done earlier that AK is equal to A minus K conjugate. Right? All right. So, Daniel, how do you derive AK is real?
सर क्योंकि इवन है ना,
Yeah,
तो a k और a of minus k सेम होगा,
yeah.
a k is equal to a k का conjugate.
Excellent, excellent. Right. So you're exactly right, right? And I think you've done it intuitively. You've said कि जी A के real होने की वजह से वो conjugate symmetric थे, लेकिन even होने की वजह से वो same होने चाहिए. तो a number must be conjugate of itself. The only number that satisfies this is a real number. I am just going to use these two equations here, right? So this equation number 1 and equation number 2, and combine them together to conclude that AK must be real, right? So what do? I just see कि so this implies that A K conjugate equals A of minus K, right? I just take the conjugation on both sides, right? So this is equation number 3, right? And then I just combine equation number 2 and 3, right? And from there I conclude कि यार ये चीज A of minus K के बराबर है और ये चीज A of minus K के बराबर है. Therefore AK must be equal to AK conjugate. And this implies that A K must be real. So the conclusion is if x of t is real and x of t is even, then the Fourier series coefficients for this signal must be real as well. Okay. Now, एक मेरे ज़िम्मे point था, I forget. Right. अच्छा, here's the point. अच्छा. So this is, for example, a question I asked in one of the exams, right? So if x of t is real and even, so I can write this out, Talha. So the conclusion is if x of t is real and even, the Fourier series coefficients must be real. Right? All the Fourier series coefficients must be real. Is that okay, Tala? Right. So this is the conclusion we make. Now here's a question for you, which is, okay, let's me say I give you signal whose Fourier series coefficients are real, right? Does this mean that the signal is real and even? Okay, I'll leave this off as an exercise because this was for example, a problem in one of the midterm exams a few years ago. Right. So question is the following: if AKs are real, does the signal have to be real and even? I mean, does it necessarily have to be real and even? Must it be real and even, or there's some other thing we're missing here? Okay, so इसके बारे में थोड़ा सा सोचेगा, and we can perhaps discuss this in the tutorial perhaps, or if you have an answer, to just show up in my office hours. We will talk. Okay. Now here's the third point: if x of t is real and odd, right? So what can we say about the Fourier series coefficients then, right? So if real and odd, we know that if, because of the fact that the signal is real, we know that AKs are equal to A minus K conjugate. Okay? And because of the fact that they are odd, the AK equals A of minus K, and this is the minus sign here, right? So this is equation 3, 4, and 5. If I combine 4 and 5, what do I get? What do I get if I combine 4 and 5? Can somebody try to do it, or maybe somebody has done it already on their notes and tell me what the answer is? Okay, real part is 0. Umar, excellent, Umar. Can you unmute yourself and tell me how did you come to that conclusion?
Sir, so a of minus k का conjugate जो है वो minus a of minus k है, तो वो only possible तब होगा कि अगर real part ना हो.
Okay, excellent. So Umar, I'm really impressed. I mean, that's very nice. You're absolutely right, and I would let others derive this on their own as well. I'm just going to write down what the final conclusion is. It turns out that the combining 4 and 5, we get ak must be equal to minus a of minus k conjugate, right? And for this to hold true, sorry, ak equals minus ak conjugate, right? The only way this is true, the only number, so for a number to be equal to the negative of its conjugate, the number must have a real part which is 0. Yeah, otherwise the condition satisfies unicity, right? So this implies that the real part of a case must be 0. Right? Or they must be purely imaginary. Right? If fx of t is real and in odd, this is what this condition should be. So if x of t is real and odd, then its Fourier series coefficients must be purely imaginary. I mean, what that means is the real part must be 0. Okay. As an example, by the way, right? As an example, x of t equals sine omega naught t. Okay. What is the Fourier series decomposition for this? How do you find the Fourier series decomposition? So what is the Fourier series decomposition for this? किसने निकालते हैं? कौन बताएगा?
सर एक केस करेंगे उससे एनालिसिस से.
All right, so you could use analysis, but we did these examples with an observation sort of a approach, but just by observation. So you could do the analysis, and I'll come to that. But we just use Euler's identity for this, right? We said this is 1/2j e raised to j omega naught t minus 1/2j e raised to minus j omega naught t. And this is something we did in the first class we did for Fourier series, right? And from here we conclude that a plus 1 is actually equal to 1/2j, and a minus 1 is minus 1/2j. And clearly x of t is real and odd, and the Fourier series coefficients are purely imaginary. So this is something we see, right? So indeed, so x of t is real and odd, and the Fourier series coefficients are purely imaginary. Okay, and you can do the same thing for a cosine omega naught t. Okay. Achha, by the way, as I think Daniel said, which is this could be an exercise. Compute the Fourier series coefficients of x of t equals sine omega naught t using the analysis expression. Right, so I'll leave this off as an exercise. Just an integration and see. And you'll find out, KG, that integral turns out to be equal to 0 whenever k is not equal to +1 or -1. And when k equals +1, it turns out to be equal to 1 upon 2j. And when k equals -1, this integral turns out to be equal to -1 upon 2j. So this is something I leave off as an exercise. Okay. Let's do a couple of examples from your. So these examples are derived from your textbook. So this is example. So what we're going to do now is just try to apply all of the definitions that we've learned to some examples directly, okay, to compute the Fourier series coefficient. So the example is the following. So you're given a signal which is sort of a square wave. Okay, so you're given a signal which looks something like this. So this is the time axis, okay, and the signal is a square waveform looking like this. It's a periodic signal. And it goes on and on. Right, and this is the time axis t. This is time 0, and this is time. Oops. This is time 2, and this is time 4, and this height is half here and minus half here. Okay. So what is the period for this, by the way? What is the period for this waveform or this signal? Or this is x of t. So capital T is what? Capital T is 4. And therefore, omega naught, which is 2 pi by t, which is pi by 2. I think I just plug in capital T equals 4. So the frequency is pi by 2 radians per second. Okay. Now, one of the things, and the so determine, this is the problem statement. Determine the Fourier series representation for x of t. Okay. Now, you could, if you wish, and I would encourage you to do it, by the way, to apply the definition, the synthesis equation that we're familiar with, also the analysis equation that we're familiar with, apply it to this and determine what the Fourier series coefficients are. Okay. However, what I am going to do instead is to use results from an example that we've done already and the properties of Fourier series to derive the result. Okay, so some known results that we know, ठीक है, उसके direct application से will determine the Fourier series representation for this signal. Okay, now just as a so recall. So this is one of the things we did, one of the examples that there in the textbook as well. Okay, if you have a square wave which looks like something like this, this is t, right? So we've actually determined the Fourier series coefficients of a square wave already, right? But that was slightly different in the sense that this is what. So that, let's say this is the square wave that we looked at, and this is what it was. Okay, ये था. This was +1, this was -1, and it stayed 0, and then went up, and then here, and so on and so forth. Right, so this is the example that we dealt with in the last class, I think. and we computed the Fourier series coefficients for this, right? And therefore, this is obviously, this would be 2, and this would be 3, and this would be 4, and this would be 5, and so on and so forth. This would be -2, -3, -4, -5, right? So, and this goes on. And the period for this is, of course, capital T equals 4, right? And G of T has Fourier series coefficients. And take my word for this, they are given by AKs, which was equal to sine k pi by 2 divided by k pi whenever k is not equal to 0 and is equal to half when k equals 0. So this is based on the example that we've done already, right? So I mean, don't fret too much if you don't know yaar ye kahan se aa gaya. So let's just take this for granted, right? So this is something we did already, by the way, right? And by the way, the height here is 1. So the height here is 1. Okay. Now here's the question. Can you write x of t as a function of g of t? In other words, is there some manipulation that you can apply to g of t so that you get x of t from there? What do you think? How is x of t related to g of t? Right? Because if I can find that relationship, perhaps through some shifting or through some additions or through some multiplications, right, I can then apply the linearity and the shifting property together and say कि g of t को तो मैंने निकाल लिया हुआ है. I don't know that already. I don't need to compute the Fourier series coefficients from scratch for x of t. Why don't I just try to relate x of t with g of t and then just apply the properties of Fourier series coefficients to make my life easy, right? So Omar says g of t equals x of t plus 1. Okay. Right. So Omar, can you unmute yourself? You're almost there. And Daniel is almost there as well. So let me talk to Omar first.
Yes, sir. वो 1 I guess मैंने वैसे बोल दिया. उसको हम basically अगर हम ऊपर shift कर देंगे y axis पे by half, तो वो वही चीज बन जाएगी. It would be मतलब high for 1 half time period और फिर 0 for the other half.
Excellent. But then Umar, वो shifting भी तो होनी चाहिए कोई time में.
हाँ जी सर, वो plus half plus 1 की shifting तो हो जाएगी.
Right. So in other words, you need to shift on the time axis as well. You see?
Yes, sir.
In order to align this g of t with x of t, this needs to go here. In other words, कि ये वाली जो चीज़ है ये 0 पे आनी चाहिए. Right?
Yes, sir.
Right. So the relationship is the following. I say कि the x of t जो है is, if I just do this, g of t minus 1, right? g of t minus 1 करते हैं तो क्या होता है कि ये सारी की सारी चीज अब यहां से स्टार्ट होती है, यहां से एंड 2 तक जाती है, लेकिन हाइट उसकी 1 रहती है, राइट? एंड देन व्हाट डू यू नीड टू डू? द हाइट इज 1, यू नीड टू मेक इट हाफ और उसको नीचे पे डीसी ऑफसेट देना है, राइट? सो जी ऑफ टी either subtract half, was that, I think, who said this? Daniel said this as well. Okay, so x of t is g of t minus 1 minus half, right? Abdullah, you say कि plus 0.5 होना चाहिए. Is that what you're saying? Or got it? Okay. Right, you can जो g of t में x of t में plus half करते हैं तो g of t मिल जाएगा, but on the other hand it's minus, right? So this is what we are going to work with, right? So this is the relationship that we've derived. Right? X of t is equal to g of t minus 1 minus half. Okay. Now, the question is, okay, what kind of properties do I need to compute the Fourier series coefficients of x? Right. The first thing is, okay, what are the Fourier series coefficients of g of t minus 1? If I compute the Fourier series coefficients for this, right, I just apply the time shifting property, and that time shifting property would just tell me Okay, the Fourier series coefficients for g of t minus 1 are going to be just ak times e raised to power minus j times k times omega naught. Omega naught is 2 pi by 4, which was pi by 2. Which was pi by 2 times t naught, and t naught is just 1. Right? Is that clear for everyone? I mean, any questions here? Right? So here omega naught is pi by 2, and t naught is 1 second. Okay? So g of t minus 1 के Fourier series coefficients here. Right? They're just going to be these AKs that we have above, multiplied by this e raised to the power minus AK pi by 2. Right? All right. What about the Fourier series coefficients of half? Let's say y of t एक सिग्नल है, वो which is just half. इसके Fourier series coefficients क्या होंगे? Any ideas? All right, Daniel, you say a naught equals half. Why do you say that?
सर क्योंकि वो कांस्टेंट सिग्नल है और उसमें कोई कॉम्प्लेक्स पार्ट नहीं.
Okay, so CK, that you're absolutely correct, right? I can do a lot of stuff. I can just use just observation, say, from the synthesis expression, right? So y of t, I know is the Fourier series representation says okay, this should be ck times e raised to the power j k omega naught t, and k going from minus infinity to plus infinity. And on the left hand side, I just have half. The only way the right hand side is equal to half is when C naught equals half and CK equals 0 for all k is not equal to 0, right? So the DC coefficient, as somebody said, so not the coefficient, A0 coefficient or C0 coefficient must be equal to half, and all others should be 0. Okay, so here's the conclusion, therefore, that the CK is equal to CK equals to half when k equals 0 and is 0 when k is not equal to 0. Okay. All right. Now, what property should I use now? Which is kr x of t, which is equal to g of t minus 1 minus half. The Fourier series coefficients for these must be equal to ak times e raised to power minus j k pi by 2, which is the Fourier series coefficient g of t minus 1 minus ck's. And Hamza, can we use the analysis equation? Yes, you can use the analysis equation. I would strongly encourage you to use the analysis equation to determine ck, and you will conclude that the only c which is going to be non-zero is going to be the k equals 0 coefficient. I think all others actually you will be able to determine they're all going to be 0, no matter what omega naught you use. Okay. All right. So what are these equal to? Right. So let me say these are BKs. Right. So BK is therefore equal to AK, remember, is sine. So let me zoom out so that you, right? So this is sine k pi by 2 divided by k pi times e raised to power j k pi by 2 whenever k is not equal to 0. What would this value be for k equals 0? What would this value be for k equals 0? So it's for k equals 0, this is a naught times e raised to power j times 0 times pi by 2, which is just 1. So this is a naught minus c naught, right? And a naught is half and c naught is half as well, and therefore this must be 0, right? So you're just subtracting this value from this value here. Okay. Or I can slightly, what is e raised to power j k pi by 2, by the way? What is e raised to power j pi by 2? E raised to power j pi by 2 is actually j. Excellent, Daniel. So this is j raised to power k times sine k pi by 2 divided by k pi. K is not equal to 0 and is 0 when k equals 0. All right. Now let's try to see, yeah, does this satisfy all of the conjugate symmetry properties that we've been talking about, right? So the original signal, what kind of a signal is it? Right. So this is the original signal. Is this real? Is this real? Is this real? Is this odd? Is this even? I mean, what kind of qualifiers does it tick? कौन से boxes tick करता है? क्यों जी? Okay, Abdullah says it's real, right? So it's yes, it is real. Any other boxes? I am talking about x of t. Okay, excellent, Talha. Right, so this is real and odd. Now, what did we find out before this? Okay, if a signal is real and odd, its Fourier series coefficients must be purely imaginary, right? So the real part for that must be 0. Okay? So is it like that? Is this like that? Is the real part 0 always? Okay, Saad Raza says yes. But Saad, what about k when k equals 2? What is j squared? J squared, isn't that 1? Or actually minus 1? Right? If j squared is minus 1, right, that means कि उसका imaginary part तो है ही नहीं कोई. और अगर जो बच गया वो real part होना चाहिए. Right? Because minus 1 is being multiplied by sine of something. And sine of something is always real. So doesn't this go against the thing that we've derived? I mean, how do you explain this apparent oddity? Right? Who is going to help me explain this apparent oddity? Do I need to pick on somebody? So the question once again is, okay, the signal is real and odd, right? So if the signal is real and odd, that means the Fourier series coefficients must be purely imaginary, right? Now, what happens? What if j? What if k is an even value, right? If k is an even value, j raised to power an even value is real. It's not imaginary anymore. ठीक है? तो फिर तो अगर imaginary रही तो I mean this goes against the result that we have derived. जी Daniel?
Sir, for even values of k जो है ना sin of k pi by 2 भी 0 हो जाएगा. Excellent.
So it's everything is consistent. So even though j raised to power k is going to be real for even values of k, right? But sine of k times pi by 2 when k is even is going to be 0 as well, right? So therefore, the even at even indices bk is going to be equal to 0, and at odd instances it's going to be purely imaginary. Okay, so it's nothing is odd anymore, right? Everything is consistent. Okay. The other thing we can verify once again is that B naught is 0. And that must be because the signal is odd. And we've found out here if the signal is odd, the DC coefficient must be 0, in which it is. Because so everything clicks together, everything makes sense. Okay. Now I'm going to stop here and take any questions that you may have. I would encourage you, however, to just take the signal, this x of t here, not g of t, this x of t, and apply the analysis equation on it. Okay, analysis equation apply करें और उससे derive करें कि what the Fourier series coefficients turn out to be, and your results should be what the results that we get here. I mean, same आने चाहिए. Okay, so this could be an exercise. Okay.